Nice. Welcome everyone to our official last day of class. So a number of things you might want to talk about today. I'm going to issue a couple final exam announcements and maybe just a quick review on how that last test went. So while I'm waiting for everyone to log in, if those of you who are in want to fill up the chat with questions, things for me to do, that would be fine. And we'll be off and running at 2:15. Better make sure I got the time right. All right, looks like it's officially time to start. We have just one activity left to cover, and we'll do that. I guess if you have any questions over it, I'll work on it today in class. If you have questions, send them to me. The final exam is scheduled. That's all on Blackboard, of course. As far as I know, it's 45 questions, multiple choice. We did trim it a little bit from the last semester where it's been 50. I was in contact with the coordinator of the course who's preparing it for Blackboard, so it will be a Blackboard test. She's working on it a little bit this week. I'll get back with you on details as far as how many questions exactly it's going to be. I'm fairly sure we were keeping the multi-choice format that we've been using on the final for the last 6 years. So I'd be shocked if it was anything different. Although if it is different, I don't know if that's going to really impact your preparation at all. And you still have to know the stuff. I found in the past that students tend to do slightly, usually slightly worse on the final than their 4-exam average, but that's not always true. And I do offer a bump in points if you score better on the final than your 4-exam average. And I'll put that up on the board here in just a second. So 7:45 for you in my late afternoon class. This class is 2:15 start time. Final exam is again on Friday. It's 12:45 in the afternoon. Here's my review session set up for this week. The next 3 days, of course, this one will be out of range for you taking the early final. So I'll go over this just this one time. People tend to, I used to put this on the view screen at the start of class, and then I get 1,000 questions. Anyway, I'm going to put it here, and then I can refer people to the video. So let's say, for example, your 4-exam average was a nice solid 75%. And let's say on the final exam, you study extra hard and you get 85%. So that's a nice, 10 points per exam better than you were doing. So what I do is I take the difference and then multiply by 2. So 85 minus 75 is 10 points. 10 points times 2, I'll add 20 points to your final exam. That's only if you do better on your final exam than you did on your 4-exam average. There'll be a little column for bonus points for extraordinary final or something like that. So that's something that I do offer. I have offered for a number of semesters. And I find that there's maybe 20% who jump significantly on the final. Maybe the students had a bad test in the beginning and this one really helped them out. About 1/3 of the class tends to get a few points on this one. About 1/3 of the class is pretty well even, final exam average and 4-exam average, and then about 1/3 of the class does significantly worse on the final exam. So there's no way any bonus points will come in there. The final exam review packet is out on Blackboard. I'm hoping you noticed it. I had it up online yesterday morning. It's quite a bit shorter than it has been in previous semesters. We have a nice stretch of days to practice for it. The stuff in the beginning is going to be the harder stuff for you to remember, I believe, because it's been a long time since we looked at limits. The last third should be pretty straightforward. It's antiderivatives and their uses, and that's what we tested on last time. By the way, the last exam for the early class had an 87% median, and for the later afternoon class had an 81%. Both of those were excellent scores. Typically, that's the hardest exam of the semester. I think one of the things that made it easier this time was the fact that we didn't do integration by substitution. So that gave you a little more headspace, I guess, to cram the rest of the stuff in. So that was really, really good. I was impressed. I was really happy with the last several questions where you had to had to understand the concept of what an average value is or what the area under the curve represented. A few shaky spots with some of you with the units. I didn't quite pick up exactly what I was explaining, but for the most part, that was done pretty well. I'm also impressed with the number of people who've been watching and viewing both the classes and then also the review sessions. So without further ado, take it away. You let me know what you want me to do today. I have on my laptop, I have 2 tabs. One of them is the final exam review packet, and the other is today's activity. The activities are due When are they due? I guess they have to be due by the start of class. It'd be nice if you could just get them done today. However, after this class, you should be able to put the finishing touches on them, I would think. Maybe even during the class, put the finishing touches on them. First question's popped up. I think it's from Aaron. He wants problem 1. Yep, problem. Go over number 1, activity 23. Sure. So this one is a lot like the ones that we did on the MyLabs, and also the ones I had you look at in the viewer guide. So we have the demand curve. Here's the demand curve. It's a downward sloping curve. Here's the supply curve. The demand curve as the price goes up, the demand slips back to low. Here, if the price goes up, the amount supplied goes up. I'm given the 2 equations. Shade the area for the consumer surplus. Consumers on the demand side, that's the demand curve. Right there is the consumer surplus. So that should have been in pen. Consumer surplus. And then the others in pencil, producer surplus in pencil. There it is, producer surplus. I'll cross-hatch that the other way. So this represents the total number of dollars that the consumer would have been happy to pay but didn't have to because the price was quite a bit less than the price that some of them would have paid. The producer surplus, that's the amount of money that the producers get to save because some of these producers would have produced at a very low price, but they don't have to because the equilibrium price is quite a bit above where those people would have. So this represents the number of dollars that the producers earned that they wouldn't have earned had the price been lower. So that's the part A. Part B, calculate the equilibrium quantity and price. So we need to know exactly what that is right there. And let's see, X is here, X is quantity demanded. And over here is the price. So we have to make sure we get our units going right. I know we've worked on other situations here where we had the price on this axis and the quantity over there. But in this type of the derivative or the antiderivative sets up better this way. So let's find the equilibrium quantity and the equilibrium price. To find this point where those 2 curves cross each other, we'll set the 2 equal to each other. So someone with their calculator, get busy here. When is 50e to the 0.02x, the supply curve equal to the demand curve equal 1,000, e to the negative 0.012x, e to the negative 0.012x. So there's the question we need to solve. Now, what I notice on this one is that both of these have an e to a power in them. And it's going to be beneficial if we can move both of those to the same side. And I guess I could do it by subtraction. I could recognize that since this is a negative exponent, I could have written that as over e to the positive 0.0125x, which probably makes it a little easier to look at. I guess there's no 5 there, was that? Negative 0.012. Okay, sorry about that. So since that was a negative exponent, I could have put it down there. And now we have the typical algebraic solution. How do we clear out an equation that has both a numerator and a denominator? And the answer is we multiply both sides of this by this exact denominator. So we'll multiply this by e to the 0.012x. This by e to the 0.012x. You can put it over 1 if you choose. Regardless, that's going to cross cancel and you'll just have a number left. So we're at 1,000. Here we have e to this power times e to that power. When you multiply 2 bases together, you add the exponents. So this would be 50e to the 0.032x. And if I'm not mistaken, I had one just like this on the video that introduced this. So now we have a couple steps left. We're in the familiar place where we have an unknown and the exponent. We've been doing those all semester long. So without further ado, I'll just get to it. Let's divide both sides by 50. We're left then with 20 is equal to e to the 0.032x. Natural log is a function that allows us to calculate what that power is. So remember, natural log asks what's the power? We want to know what power this is that gives us a 20. So the natural log of 20 is exactly that power. That's equal to the power of 0.032x. And now to solve for x, we'll divide by 0.032. And now is when I'm going to need the calculator out. So I did the algebra by the typical algebra steps. I got rid of the fraction. Someone with calculator help me out here. I got the typical work out of the way using algebra, clearing that off to one side. Used a little algebra to express that to the correct power, and then did the typical solve for an unknown inside the exponent. So what do we get here for x? What's the equilibrium quantity? I'm going to go back and look at the graph, because the graph lets me know whether or not I got it close. It's between 75 and 100. I would guess it's maybe a touch over 90 just by looking at the graph. 93.61. Okay, let's just go with 94. Huh? All right. So 94 is the equilibrium quantity, and there's going to be some rounding errors in this. You know, it's a few cents here and there. I'm not going to sweat that at all. So here we are right at there at 94. Now I want to make sure I know what the price is as well. I need that equilibrium point. So I have the x value of 94. I can take that 94 and either plug it in the supply function or the demand function, and I should get that equilibrium price back. Now what I'm going to do is I'm going to have you plug it into both. Again, this was had a little rounding to it, so when you plug it in the supply and plug it in the demand, you're not going to get the exact same number, but it'll be pretty close. So let's see what we get. I'll have again have some help here. The supply curve, go back and look at that real quick. Supply curve would have been 50 e to the 0.02 times 94. Someone calculate that out for me. And then someone else on the demand side, the demand, if I plug in 94, should have been 1,000 e to the negative 0.012 times 94. And again, looking at the graph, that appears to be a little over 300. I guess about 3 1/4, maybe 325. So yeah, so plug in this, plug in this. Tell me what you get for this, the supply price, and what you get for the demand price if the quantity in both cases is 94. And we'll sort of take the average of those two, sort of split it down the middle when it comes time to figuring it out. Okay, so the S was 328. I like that. I mean, that's right on where it should have been, huh? Supply is 324. Okay. So let's split the difference. Let's call it 326. And again, why did you get slightly different numbers? Because the more correct answer would have been, what, 93.61 or 62? That would have brought those two closer and closer together. You know, it's just $1 or $2 here in the long run. I don't really care about it. It won't matter that much on the final. It won't matter that much on today's activity. So now let's set up those two quantities that were asked to find, I believe, both the supply and the demand surplus, right? Consumer surplus is part C, yep, and producer surplus. Okay, so we're going for the top one first. We're going for all this money that the consumers don't have to spend. Some of them be willing to have a really high price, spend a really high price. They don't have to. So let's find that one first. That's a demand curve. I'm going to keep that right there. So now we're right back to where we've been, what we've been doing lately, area between two curves. We know the boundaries, 0 to 94, x is 0, x is 94. This is, again, what we're trying to find for the consumer surplus. We take the upper function minus the lower function. The lower function we decided was 326 right across there. So the upper function was 1,000 e to the negative 0.012x plus, whoops, bigger function minus the smaller function. There we go. So just as we've been doing, we have our parameters are 0 and our 94. Upper function listed, lower function listed. Let's take the antiderivative. Well, in this one, I'm going to have to divide this 1,000 by the of that reciprocal. So my number up front will be 1,000 divided by negative 0.012. I have my little toy calculator here. I can do that one. $833.33. Okay. So the antiderivative here is 83,333 e to the negative 0.012x minus 326x. Now we're going to evaluate that from the high point to the low point and then subtract the difference between those two. So I'm going to have someone help me with the high one. I'll do the low, and I can plug in x equals 0 and do that mentally. Someone please calculate this when x is equal to 94. When I put in, hang on, this came up negative. Yeah, the antiderivative was negative 83,333 e to the negative 0.012x. Dividing the 1,000 by negative 0.012, that's that coefficient. So if I plug in 0, e to the 0th is 1. And 1 times any number is itself. So the number when I plug in 0 is negative 83,333. What do we get when we plug x equal 94 in? We'll get a number that's not quite as big, or not quite as negative, I guess would be a good way to say it. So someone take the 94, plug it into the antiderivative. Tell me what you get. All right, 26,973. That seems good. 26,973. And that was negative, was it not? Oh, we got two different. Oh, hang on a second. So negative 57. Yeah. I see where you're going. Good. Okay. So plug the first one in. We got negative 57,617. So we have negative 57,617, and then we're going to subtract off negative 83,33. Let me write this a little clearer. 57,617. So we have this number minus this number, and when you do that subtraction, I'm guessing that's what you have there, Isabel. Sure seems to make sense. Okay, so when you do that subtraction, with a little rounding here and there, and we're within a couple of bucks, I'm going to be happy with that. So at 26,973. I'm going to just double check that real quick on my calculator. Let me try that one more time. All right, so I got something a little different. I didn't get that when I did the subtraction. Yeah, I'm with you there, Aaron. Yeah, so doing the subtraction, 25,716. The units here are dollars. That's the number of dollars that the consumers were able to save. Again, some of them would have gone for a higher price. They didn't have to. The equilibrium price came down to 326. And I have a story about how businesses try to milk this. This is money that they're wasting. There are people willing to pay this, but they don't have to because the price is set low. I'll show you how the business makes sure they can soak every cent out of every possible consumer with a story that goes way back. I'll end today's procedure with that. All right, there we go. Excellent. So we're in agreement on that one. So first problem, surplus problem is done. Now let's go for the producer surplus. And just looking at the graph, I know that the area here is quite a bit bigger than the area there. So I'm guessing that this one will have a little smaller number of dollars. The producers won't have that many surplus dollars in there. So let's see, producers, I need the surplus side. Got my green marker here someplace. Yep. That's the area we're looking at here. Once again, we'll set up the definite integral. The limits are going to be the same. The functions are going to be different, however. I want the upper function, that's my constant 326, and then subtract the lower function, which is the supply curve. So subtract off from that 50 e to the positive 0.02 times x. Follow that with a dx. Oh, one of the things I was most thrilled about on the last exam is whenever I had a antiderivative and you had to give me what the antiderivative was, almost all of you did not include the antiderivative signs. I don't know if anyone put the dx at the end. That was one of those things that was a strange set of circumstances over the years where people would take the antiderivative and just keep that antiderivative sign there. And I think a few of you were doing that on the quizzes, but you weaned yourself away from that. Anyway, taking the antiderivative, that's easy. That's 326 minus 50 divided by 0.02. I think that's 2,500. I'm going to check real quick. $2,500 it is. Yep. Again, we're going to evaluate this between 94 and 0. Both of those, I'll do the bottom one. I can do the bottom one mentally, I think. Oops, wait on. Yeah, forgot the x. Antiderivative of 326 is 326x. Yeah, I'll definitely do the bottom one. I can plug in 0 there. If I plug in 0, this one comes out to be negative 2,500. So someone please plug in the 94. Tell me what we get for this function plugging in the 94. And then for our full producer surplus, we'll take whatever we got in that box, subtract off negative 2,500, and that'll give us exactly, well, at least approximately. So what do we get here for this top number when we plug in the 94? $14,260. And if that's correct, it looks like the final thing should be what? let's see, 14,260 plus that would be 16,760. I'm waiting a confirmation on that number. If I get a confirmation, I'm ready to move on. Did anyone make sure they got that 14,260? If anyone else out there got that same number, I'm ready to move on. Yep, add those two together with 16,760, which is quite a bit less than we had for the consumer surplus, which makes me think we're pretty well right on. So that's the number of dollars that the suppliers are making. That's addition to what they might have expected to make had the price been lower. So let's call that one good, shall we? Any more questions on problem number 1? Okay, I'm going to start problem number 2 for you because I know in the past students have struggled a little bit with how to find the equilibrium point. So in this case, we have both supply curve and demand curve are concave down curves. Last time, I think they're both concave up. And we need to find that point. And to get that, we're going to set those two functions equal to each other. So I'm going to rewrite this in a slightly different form. 0.5 is the 1/2 power, so that's 60 times the square root of x. And this is 80 times the square root of 50 minus x. Oh dear. I just remember that's one that we don't know how to take the antiderivative of because that would require the integration by substitution. We'll get to that in a second. But for right now, if you saw this equation and you wanted to try to solve it, what might you do first? So here we are, problem number 2 at the very start of the equation. Or very start of the problem, we want to find the equilibrium quantity and the equilibrium price using algebra. I'm going to go ahead and shade this in again. Here's the producer surplus. I'll go low right, up left. I'm sorry, that's a consumer surplus. And then the producer surplus, I'll put in green. There we go. So if you saw this equation, what technique might you want to use? And there's really no right or wrong answer here. There's 3 or 4 different ways to get this one to go. But what suggestion might you have for me or how to solve this equation that's going to help us find the equilibrium point? Yep, let's square both sides. So 60 times the square root of x times 60 times the square root of x, that's 3600x. 80 times that square root, 80 times itself. 80 times 80 is 6400. And square root of 50 minus x times the square root of 50 minus x is 50 minus x. So now you have it in really good standing, right? Distribute the 6,400 through, get all the x's to one side, all the other numbers to the other. After a couple of steps of algebra from here on, and it's just the basic linear algebra from there, you should be able to come up with a value for x. And I'm going to zoom in on my screen a little bit so I can have an idea what it's supposed to look like. 25, let's see, 5, 10, 15, 20, 25, 30, 30. It looks like it's 30 some maybe. Five, 10, 15, 20, 25, 30, 31, 32. I'll let you carry through the algebra and let me know what you get there for the equilibrium quantity. And I think just by rewriting that with the square roots there now becomes obvious, or at least a lot more obvious what to do when those are both 0.5 powers. A little less obvious. So there's one of the reasons I was working on early in the semester, rewriting things from one form to the other. It's a lot easier, I've found, to evaluate things if they're in the square root formula. It's easier to see how to do things if they're in the square root formula. But the laws of exponents are really something where the exponent rules for both derivatives and antiderivatives really force us to write them with the powers as numbers. So solving this through in a few more steps, what do we get for the value of x? Got 32 exactly. Okay. And that looked to be pretty accurate. All right, so now we should be able to plug that 32 both into this one and into this one, and we should get about the same number back again, depending. Well, it really shouldn't be any rounding at all because 32 came out spot on exactly. So if we plug 32 either in for this or 32 in for this, here is our supply, here is our demand. What value do we get for the equilibrium price? So one more nice thing about having both the supply and the demand curve is you can verify that you get this number right by plugging it into both, and you should get the same, at least approximately the same number back. So plugging in 32, that's a square root. I don't think my simple calculator does that. 339. Right, I'm going to check on the graph really quickly, see if that makes sense. 300, 10, 20, 30, 20, 40, 60, 80, got 320. That's 325. Okay, yep. 339 it is. All right, I'm going to let you folks figure out the easy one, which is the producer surplus. I'm going to look at the consumer surplus. Yeah, the consumer surplus, that was my demand curve. Double check that just to make sure. Yep, there's my demand curve. All right. So for my consumer surplus, I'm going to take the antiderivative from 0 to 32. My upper function, which is 80 square roots of 50 minus x, minus my lower function, which is 339. So the area between this concave down graph that's decreasing and my straight line across. Follow that up with a dx. Okay, that one is easy, negative 339. And this one is just a little funky because we have something under here that we're unable to take the antiderivative of because we had not learned the integration by substitution. So what I'm going to do is I'm going to do pretty much the same steps I did before. I'm going to keep the 80. I'm going to keep the 50 minus x. I'm going to raise the power by 1, so now it's going to be to the 1.5 power. I'm going to divide it by 1.5 because that's the way things have always worked. But notice inside, if I were to take the derivative of the inside function, there'd be an extra -1. So this requires another -1. Don't worry about it as far as having to do something like this on the final. It's not going to happen. But this is how that function, that's how the derivative or the antiderivative for this one would have gone. So some of the rules were the same. Raise the power by 1, divide by that new power, and now we have to multiply by or divide by the derivative of the inside function, which is -1. So let's take that 80 divided by 1.5 and see what that comes out to be. So a -1613 times 50 minus x to the 1.5 minus 339x. There's the antiderivative that we have found. That's what we need to find our definite integral. Evaluate that at 32. Evaluate that at 0. And you're going to get different numbers for both of those. So why doesn't someone tell me what that is at 32? Someone else calculate what they get when they plug in 0. I'll put the minus sign between them, and then we'll calculate out how many dollars the consumers would save. So this has got to be negative something, and that's got to be negative something as well. So for 32, got negative 134,029. Okay. Anyone working on the bottom one? Wrap this one up. Okay, negative 570, 282. Okay, so this one plus that, and then we will have the consumer surplus. I'm going to leave the producer surplus up to you. That's really pretty straightforward. I'll set it up, I suppose. So producer surplus, we're looking at the area there in the green. Upper function minus lower function. 339 is the upper function. I erased my lower function equation. Lower function was 60 e to the 1/2. 60x to the 1/2 dx. Right. I'll leave that one up to you. Now the last page on this activity is pretty well review. It was the stuff that we covered on the last exam. If you have any questions on that, hey, let's look at them now, I guess. Huh? This would be good practice as far as getting ready for the final is concerned. So the only new material we had today was this stuff right here. Everything else is stuff from the past. Nope, no quiz today. There's no new material. This is the first day of the semester. I've been able to open the window during one of these sessions. Feels nice. We still have half hour left in our time together. I'm willing to look at any questions you may have. If you want to explore anything more on this activity, that'll be fine. If you want to look ahead a little bit at material that's prepared for you as far as getting ready for the final, that'll be fine. My suggestion is, you get this done and get it submitted as quickly as possible. That'll make grading go a lot easier. It's still a struggle for me to stare at the screen for a very long time. So what I'd like to do is get these activities done and graded probably Thursday. I know some of my helpers are busy preparing for their own finals, so they're not going to be able to grade as much as they have been. So if you can get these in, today, tomorrow, Thursday, if I get them graded Thursday, that way Friday I can spend my time grading the final exam. Although I guess if it's all multiple choice, there won't be much grading. No. Anyway, get them done as quickly as you can. I'd appreciate it. And we can certainly spend some time tomorrow. If you have any questions over how to complete this, we can certainly do that. What I plan on doing tomorrow, by the way, is looking mostly at the first half of the review packet. So I'll take questions from the first half. Maybe I'll just sort of go through in order. Maybe that would make the most sense. and then Thursday we'll go through the second half. Yeah, that sounds like a good plan. So maybe an hour and a half each day. I think we should be able to get through the whole thing in 3 hours. Anyone have any questions? Yeah, there's a set time for the exam. The exam, it will open up depending on when you have class. Set time, this is again going by the official final exam schedule. I know there's a few students who've picked up some jobs and have been unable to meet during the regular exam times, and that's fine. Just let me know when you want to take it. The 215 class is scheduled for 12:45 this Friday, and the 345 class is scheduled for 7:45 in the a.m. again on Friday. And those should be right there, the very first thing when you log into Blackboard. All that information is there. Yep, 7:40, 3:45. Yep. Make sure you notice that this is an AM time on Friday, so I'll be up early and you'll be up early as well, I guess. Part A of number 3, sure. Oh. Taken almost exactly from the last exam. In fact, this was probably the one question that people messed up the most. So we have the marginal cost function. We want to find the cost function, and we know the fixed cost is $2,500. So MC of 0 is 2,500. We'll take the antiderivative of 500 times x plus 100. I guess we have another one of those situations where you're going to use the power rule on this one. 500 is a constant multiplier. We're going to keep that. We're going to keep the x plus 100. We're going to raise the power by 1, 0.75, and we're going to multiply by the reciprocal of that new power, 1 over 0.75. Then we'll add a plus c at the end. So let's see what we get. Oh, I lost my calculator. Doggone it. There it is. So 500 divided by 0.75, that's got to be a crap fraction. 667, we'll call it. So it's 667 times x plus 100 to the 0.75 plus c. Now here's the mistake that so many of you did on the last exam. You just let that c be this number. That is not correct. What I know is when I plug in 0 for this function, I have to get 2,500. So 2,500 has to be 667 times x plus 100 to the 0.75 plus some number c when this x is equal to 0. So I take this function, I set it equal to what the cost is when X, when the number manufactured is 0. So 2,500 is equal to 667 times that plus C. Let's see what 100 to the 0.75 is. That's about a 31.6. I'll multiply that times 667. I get about a 21,090. So 2,500 is 21,092 plus C. And then I can solve for C. So C in this case comes out to be negative. Negative 18,592. There is my cost function. So there's this tendency for so many, and I don't know how many activities I did this on where we plug in a 0 and it wouldn't cancel out, and this is not the value, but that was just a recurring error. And I think I think that's probably why I put this on my activities in previous semesters, because students kept making that error. And that's one of the questions that has typically been on final exams for as long as I've been teaching the course. We have a problem like this. We go through, find the antiderivative, and we have to use the fact that when we plug in 0, we get this, and this is not necessarily the constant at the end. Now, if we started with a polynomial, sure, that's all well and good, but if we don't, then it's got to be something else. So make sure you pay attention to the fine print, because one of the answers will have, the wrong answer will be this will be the C, and one of them will have the right answer. There's two things that you can make sure you have to get this problem right. When you take the derivative of this, you should end up with the function you started with. And the other thing is, when you plug in 0, you should get 2,500. Plug in 0 here, make sure that comes out to 2,500. So again, that's my one big caution on that one, right? So there it is, part A. And the rest of this problem then is sort of the conceptual ideas. What does the area under the curve represent? What does a designated part under the area represent? So that was 3A. Any more questions? Well, I hope you can all join me tomorrow, if not tomorrow, the next day. And if you can't join me either day, make sure you watch through the watch as we work through the review problems. That'll really help as far as getting ready for the test on Friday. My suggestion is that you close things up today, open that review packet, work as many of the problems as you possibly can. Notice that both the questions and the answers are available for this one, so I did have a review packet answer key as well. Get as far through, and you're not going to get all those from the beginning. Get the ones that you can get. Circle the ones that you're having trouble with, so that when we get to them on the review day, you can just sort of focus in on exactly the ones you need to focus in on. If you want to work it backward, that might not be a bad idea either, because the fresh ones, you can see how well you know those. You might start getting trouble 2/3 of the way back in the class. But whatever you want to do, it doesn't really matter as far as prepping concerned. But the biggest thing is practice the practice problems. Look at them ahead of the sessions the next couple of days. Do as much of those as you possibly can. That's how you're going to learn the material the best. Okay, we'll look forward to seeing many of you in the next couple of days. Bye now.